All right, I'm going to give a brief overview of the three-door or the quad biparting track system, a three-motor system basically. So I've set up three motors here that are actually the same motors we're using, and I've just put a wheel on it with an indicator so it's easy to see the motion. So the first one is the door number one, which also has the button on it that will be able to operate from the button that's mounted on the door. Here's door number two, which is the opposite of door number one, and here is simulating door number three, which is really doors number 3 and 4, which are the biparting systems. So just a quick description of what's going into the space for the controllers. Here's our remote control transceiver here that will mount on the back of the door. Here is the receiver for that. I've got the key fob connected to a button here labeled door, in which case we'll have two of these buttons mounted on the door, one on each side. I've got some buttons here labeled simulating home automation controls. These actually won't be on the system, but I'm simulating what the Crestron or Lutron or whatever the system will be is going to be controlling. So we have close all, open door number one. If all the other doors are closed, that will open up one. And actually, no matter where the doors are, if you press open one, all of the doors will move to the correct position and door number one will be open. Open doors 1 and 2, stop, and in fact, if any doors are moving, if you press any button, the system will stop. Here is a LCD touchscreen that is set up as a synchronizer for all three master controllers. So here is for door number 1, door number 2, and door number 3, and 3 and 4 if you want to call it that. So what the synchronizer does is it connects with a cable via RS-45, daisy chained in and out of all of the systems over the RS-45 ports here, all the way down to the last port. And then we're monitoring on the scope the RS-45 communication between all of the systems. So this touchscreen lets me monitor the status of all of the doors, the position of all the doors. In this case, they're at 0 inches. They're all open. Let's go over a couple more things. Here's a battery backup for the encoders. All of the motors have an encoder on them to store the position, and this battery backup is a 12-volt lithium battery with a charger. And what happens is if the power goes out, this battery will keep the position of the doors for maybe 3 or 4 days. I have also added a UPS battery backup. All of the doors are currently running on battery backup, and I'm testing to see how many hours I can get off of a 900 volt amp APC. So next we have home switches here, which are already built onto the tracks. So this is home switch for door number 1, home switch for door number 2, home switch for door number 3. Okay, we'll probably have an outlet in the top here. I just put that there to simulate a position. We may have this strip in the middle. That'll be determined later, but I think the APC will mount perfectly in the bottom, and I built this cavity for the specifications of what we have talked about the sizes would be, and it does need to be 4 inches deep. So let's see, I guess we could test this. All of the doors have been homed. What that means is all of the motors, all of the motors simulating the doors are in a valid state, and you know it's valid because I have the software analyzing all the positions of the door, and it lets me know that everything is in a state that is acceptable. So what I'll do is I'll simulate on the screen, or I'll do the motion on the screen, and then we can simulate it with home automation here. So first, let's do close all, and you can see all three doors have moved to the correct position. let's do open all. All three doors are opening. Let's do close all again from simulating home automation. And as you'll see, door number 3 always stops early when you're closing because it's only moving half the distance. Now let's do open 1. So in this state, all 3 doors are closed. And you can see that in this test, the doors number 1 are at 30 inches, door number 2 is at 30 inches, door number 3 and 4, I just call it door 3, but it's technically the biparting system, they're at 15 inches because they move half as far. So I am going to test opening door number 1. We could do that either from the screen, or let's just simulate our button mounted on the door, okay? Door number 1 is opening. The other doors are staying still. They're fully closed. Okay, in this state, let's go back and close all. So now, all doors are fully closed. 1, 2, and 3 closed. Now, if we want to, we can go to another screen that lets us configure some settings here. So right now, auto close is turned off for door number 1. So we only are using auto close on door number 1 ever. It's the only door that can be auto closed. So if we turn auto close on this screen, let's go back to our normal screen. Now let's, and keep in mind, we're still, all doors are closed. 30 inches, 30 inches, and 15 inches for door number 3 and 4. Okay, now let's do an open from our remote control door button. Here we go, it's opening up. And then after about 2 seconds, I got a very short delay for testing. Door number 1 closes back. And you can see that the other doors are still in the closed position. So all of the doors are closed. Let's simulate that one more time from pressing the button on the door. You can see that door number 1 is moving. It is now at 15 inches in the middle position. After a few seconds, it is moving back closed. If we want to, we could go back, turn auto close off, and then if we want to just leave door number 1 open, we can press open door number 1 and it will stay open indefinitely. If we want to go back to the door button, we can press close and it will close. So we have a couple of different methods of how we could operate door number 1. Now all doors are closed, 30 inches, and 15. Okay, now let's simulate opening up doors number 1 and 2 to the middle position. You can see doors number 1 and 2 are opening, and they will stay there indefinitely. Let's close all of the doors. Okay, is there anything that we did not do? If we're opening, all the doors are currently closed. If we are opening all the doors and I press stop, the doors stop in their current position and they all give me an indication of somewhere in between a state. This one's at 1 inch. Doors number 1 and 2 are at 15, 16 inches out. Okay, in this case we could open all and continue in opening the doors, and we could close all. A little bit more about wiring. We will have some electricity coming in somewhere on the top of this space, and the battery has a charger that needs to get connected to an outlet. All master controllers are currently plugged into the APC. There is a wall adapter that goes to the LCD touchscreen. There is a wall adapter here that's in the APC because I want it to stay on if the power goes out for some period of time. This wall adapter goes to the remote control, and you can see if I press door number 1, you can see that light up. Oh, one other thing I didn't show you. Let's open up all doors. So or close all doors, I should say. Okay, all doors are closed right now. Let's open all the doors. Now, when all of the doors are fully open, 0 inches, they're fully in the pocket, I can press the open 1 button and all of the doors will close and door number 1 will go to the middle position. So you see doors number 1, 2, and 3 moving, and now we can see that door number 1 is in the middle position, door number 2 is closed, and door number 3 is closed. And so basically these buttons cause all 3 doors to go to a state. Okay, the state can be reached from any position that you're in. All right, that's pretty much it. I will do another video that shows a little bit more technical stuff. One other thing, let me see here. I have a setting, a couple of buttons going on the screen that have not been programmed yet. Store 1, 2, 3 close position. So in other words, we can take the door, all of the doors, and move them to the position we want for the fully closed position, and then press this button and store that position permanently. Then we can move the doors number 1 and 2 to the middle position so that doors number 3 and 4 are fully closed. Doors number 1 and 2 are in their middle position, and then we can store that position straight from the screen. We can turn the motor on and off here. So if I turn it off, you can see a red light come on that says the motor's disabled, so we can move the door. I will turn the motor back on, light goes out. Motor's off, motor's on, off, on. When the motor's off, we can move the door by hand. When the motor's on, the motor does not want you to move it. It wants to fight you to keep in a position. If we turn the motor off here, then we can move the door to a position and store that position, or move the doors manually, whatever the case is. Alrighty.